All right, good morning or perhaps good afternoon. Suppose that depends upon the time zone that you're joining us today from. I'm Tim Panfill, Senior Director of Graduate Admission and Enrollment Management for Elmhurst University. And it's absolutely my pleasure to welcome you to today's Lunch and Learn, Demystifying the COVID-19 Vaccines. We've got an information-packed webinar planned for you today, but before I turn the mic over to Dr. Molly Tran, I want to review just a few tips to hopefully maximize your Zoom experience. First, we suggest choosing speaker view from the drop-down menu on the upper right-hand portion of your screen. Second, until we get to the Q&A portion at the end of the webinar, we ask that you do remain muted. When we do get to the Q&A portion, please feel free to either type your questions into the chat box at the bottom of your screen or go ahead and unmute yourself and ask your question live. We are recording the webinar and we'll send you all a link within the next few days. Please feel free to share it with anybody that you know who might be interested in learning more about the vaccines. Finally, today's event is being hosted by the Office of Admission Graduate Studies and sponsored by the Master of Public Health program at Elmhurst University. You'll have a chance to learn more about our graduate program in public health a little later on. But now, I'd like to introduce our presenter, Dr. Molly Tran. Dr. Tran is board certified in occupational medicine, a clinical assistant professor in our Department of Nursing and Health Sciences, and also the program director for the undergraduate and graduate programs in public health. Her research interests include the work-related health of gig workers and transdisciplinary methods in public health. She's regularly provided commentary for media outlets on issues related to gig work and health. True confession, I have absolutely no idea what that means. So at this point, it's probably best that I just turn the Zoom over to Molly.
Thanks, Tim. I'll talk your ear off about all that a different day. But for now, today we're going to talk about COVID and the COVID vaccines and what all that means. So let's see. Did we both click sharing? Okay. All right. So let's just start a minute. And thank you, by the way. Thank you to everyone for joining us and for spending your lunch hour with us, and hopefully you'll come away with a better understanding of the vaccines. And I look forward to hearing your questions at the end. But let's start by talking about what is COVID. So I think at this point we all know, right? The disease itself technically is called coronavirus disease or COVID-19, and it's caused by a virus, the severe acute respiratory syndrome coronavirus 2 or SARS-CoV-2. And of course, the coronavirus name comes from all these little spike proteins around the surface that are represented in the orange there that give it that crown-like or coronavirus name, and that's really just kind of the family of viruses. So there are other coronaviruses out there. Oops, I'm hitting the wrong button. So what is a virus? Let's start with that. So a virus is just a category of germ, just like a bacteria or a fungus. I think about viruses as they're extremely tiny. So you can see that in that first picture there. And they're really just an infectious agent that is basically only made of a nucleic acid molecule, so some genetic information inside a protein coat that just keeps that genetic information in place and secure. So in contrast to a bacteria that is a single-celled living organism that can do all the things that a living organism has to do, is like bringing in nutrients and getting rid of waste and dividing, reproducing itself. A virus can't do that without being inside your cells or being inside, a living cell. So viruses themselves are not living. They need a host cell, in this case of COVID, your cells, to reproduce. Other than that, though, bacteria and viruses, they can cause pretty similar illnesses. So you can have, a respiratory illness caused by a bacteria or by a virus. You can have a stomach bug that's caused by a bacteria or a virus. And they spread in pretty similar ways. So either one can spread, by aerosols like COVID, or by touching surfaces like other illnesses. So what does COVID do? So we said COVID can't live and do the things it needs to do to reproduce on its own outside of your cells. So what it does is it uses that spike protein that gives it the coronavirus name, to actually be kind of like a little key. And it uses a receptor on the outside of your cell as the lock. So that receptor, in this case, is called ACE2. And your cells in your body are all covered with different kinds of receptors that help the cell do the different things it's specialized to do. So in this case, ACE2 is a receptor that normally has a good function in your body that has to deal with sort of fluid levels in your body, fluid balance, blood pressure. If you've ever taken an ACE inhibitor for your blood pressure, that's that family of receptor. But COVID is also, the virus is also particularly good at unlocking that receptor and using it as sort of a door to get into your cells. And once it does that, it gets into your cell and it uses the machinery that your cell has for its own purposes of making proteins and of reproducing itself. It uses that machinery to make more copies of the virus, which then go out and infect other cells in your body, and on and on and on and on. So, that kind of helps explain in a way what or why COVID does all the things that it does. Because, this time last year, right, we were kind of hearing like, oh, it's kind of a flu-like illness, right? It's a respiratory thing. And then all of a sudden, it was COVID toes, and it's causing strokes and pulmonary embolism or pulmonary emboli and, heart attacks. And what is going on? GI stuff. Why is COVID doing all that? Well, really, it's because it's going wherever in your body that receptor is, and it's infecting those cells. And that receptor is all over your body because it's really prominent in basically the blood vessels, and your blood vessels go everywhere. So that's why, sort of a quickie explanation of sort of why we see such varied and diverse symptoms from COVID. So let's talk a little bit about how a vaccine works before we get into the specific vaccines. And to do that, we're going to have to go back to high school or college or whenever you last had some physiology and talk about the immune system. So, of course, the job of your immune system is to distinguish self, your own cells, from non-self, things like bacteria and viruses, and attack the non-self and keep the self safe, right? And it does that in a lot of different ways. It's a very complex organ system. It's probably one of your biggest ones because there's a lot of different parts and pieces that work together to do that. So, for example, your skin and your saliva and your tears, those are all parts of your immune system because they are what we call barrier immunity. So they act as a first line barrier to keep viruses and bacteria and things from getting into your body. Should virus or bacteria get past that, right? Get in, for example, with COVID, that's getting in through our mucous membranes, right? Our noses and mouths and things like that. Then we get into what we call cell-mediated immunity. And that just means it's the kind of immune system that your white blood cells are doing. And even that, there's a bunch of different kinds of cells. But today we're just going to focus on B cells. And we're going to focus on B cells, which are a type of white blood cell, because they make antibodies. What are antibodies? They are these little proteins, everything's a protein, that are generally Y-shaped. And in that Y, they have a receptor. Again, sort of another lock and key situation. A receptor that's specialized for any given bacteria or virus that you might encounter. And what the antibodies do is they go out and they circulate through your bloodstream all over your body. And when they encounter, that bacteria or virus that has something on its surface that it can kind of lock onto, it locks on and it sort of acts as a flag, and it tells these other cells in your body called macrophages, which are kind of like Pac-Man, to come and gobble up that bad cell and get rid of it. So if your immune system is sort of like a search and destroy mission, right? The antibodies are sort of the search, and the macrophages are sort of the destroy part of it. Now, the thing is, excuse me, the antibodies they're very specific to any type of germ, right? So the first time your body has seen any new bacteria or virus, it takes a little bit because your B cells are manufacturing this new, specific antibody that is, it is specific to that kind of germ. So the first time it takes a little bit to get that manufacture going, right? It takes a few days. And in that period of time, the germ or the virus can kind of get a foothold in your body and reproduce itself and get going enough to make you have symptoms of being sick, right? It can affect your cells enough to make you feel sick. Then your B cells ramp up that antibody production, your immune system, gets to work, clears it out of your body, and you're done. And after a bit, your body stops expending its energy on making those antibodies, and the levels kind of wane and go away. The cool thing is there are also these B cells called memory B cells. And what they do is they remember. So they kind of go dormant in your body until you see that same bacteria or virus again. And then they go, I know this one, I got this, don't worry about it. And they can immediately, very, very quickly produce those same antibodies and fight off that bacteria or virus, so that they can do it actually before it's gotten a chance to get a foothold, and you actually, fight it off before you get sick. So that's the basis really of simplified. There are other cells involved, but it's beyond what we need to get into for this talk. But that's a simplified basis for immunity, whether that's immunity you get from having a disease and then being immune to it, something like back in the day, chicken pox, when we used to get chicken pox and you didn't really get it again, or from immunity from vaccination. So really what vaccination does is it just takes advantage of that mechanism. So instead of having to get sick before you get that immunity, you're able to get that immunity from the vaccine. So vaccines typically contain either a whole bacteria or virus that has been either weakened, it's still alive, but it's weakened, so it can't give you, the illness, or it's been killed, but the physical protein and thing, are there for your body to react to, or it's maybe some part of the bacteria or virus that's injected into your body for your immune system to react against and have that response against. So again, the whole idea is that instead of having to get sick to get that immunity, you get this, either killed or weakened or partial, bit for your body to react against, and you get that immunity without even having to get sick, which is a great deal, right? When you think about it. And of course, the corollary of that, right? If you're one of those people who says like my sister, right? I always get the flu from the flu shot. You don't, you can't. You had sort of an inflammatory reaction where you felt kind of, crummy for a day or two, but you did not actually get the illness. Now, let's talk about the specific coronavirus vaccines, because there's some things that are really neat and exciting about them. So there are a bunch of COVID vaccines. Actually, different countries, China's manufacturing their own, Russia, Cuba, so other countries are manufacturing their own. But let's talk about kind of the main ones that you're hearing about on the news every day. And there are really two categories. So we've got the mRNA vaccines, and I'll tell you what that means in a minute, which are the Pfizer and the Moderna. And those have been the two that you could potentially get in the US up until hopefully next week. And then there are two DNA vaccines. So there's the Johnson & Johnson, which any minute now, over the weekend, is probably going to get approved by the FDA for use in the US. And then there's the Oxford AstraZeneca vaccine, which has been primarily been used in the UK and the EU. All of these are 2-dose vaccines, except for the Johnson & Johnson, which is a single-dose vaccine. So again, it's pretty exciting that that's coming online. So what's unique about the COVID vaccine? It's that instead of injecting the virus or a piece of the virus into you, it's actually injecting the blueprints or the recipe to make a piece of the virus. So for the COVID vaccine, it's injecting the blueprint to make the spike protein, whether that's mRNA blueprint or the DNA blueprint. You're making copies of the spike protein. So let's talk a little bit about the mRNA vaccines. That's the Pfizer and the Moderna vaccines. So when we talk about mRNA, now we got to go back to bioclass again, right? And if you remember, right, all the instructions of how to, make the things that sort of make up you are encoded in our DNA. That gets transcribed into RNA, and then that gets translated into proteins. And proteins, we always are taught, they're the basic building block of life, right? So they make everything. They make things that, do functional stuff like receptors. They make structure, of many things in your body. And, it all kind of depends on the order of them and how they fold up as to what they do. And that's why you have these instructions. Now, this all happens inside your cell, right? So your cell, very simplified, has the nucleus that's sort of like the head office, right? And it has the instructions. It contains the DNA. Inside there, that gets transcribed to the mRNA, which is kind of like a little Post-it note that goes out into the cytoplasm, the rest of your cell, kind of the goo part of your cell, and gives the instructions for how to make the protein, right? So it's sort of the nucleus is the head office. It sort of sends that Post-it note of the mRNA out to the factory floor and says, ramp up production of this particular protein. That mRNA is really a very sort of fragile, meant to be short-lived thing, because it's really only built to last that sort of infinitesimally small distance between the nucleus of your cell and the rest of your cell. And of course, your cells are teensy, teensy tiny. So that will come up to play later.
Yum.
But what the COVID mRNA vaccines do is they use the same mechanism. So the vaccine itself is basically just a particle of mRNA that says, make the spike protein, and it's covered in a lipid bubble, just kind of a little fat bubble that just is sort of the thing that keeps it safe until it can get into your cell and delivers it into your cell. So it delivers it into your cell uses that, factory floor machinery. The mRNA doesn't even go into, the head office. It doesn't go into the nucleus. It just stays out in the rest of the goo of your cell, uses that machinery, makes the spike protein, and the spike protein goes out into the rest of your body, and your B cells and have a reaction to it and make the antibody, and there you go, you get your immunity. The nice thing about that is that because it's not growing whole virus, you're just putting kind of instructions for a piece of the virus. You don't have to sort of grow it up in cells. And that ends up being really nice because we don't have a lot of the same sort of allergy concerns as we would with other vaccines. So because it doesn't, require us to grow virus, we don't have to use antibiotics, we don't have to use preservatives like the aerosol. There's no cell lines used in the production, and there's no concern about things like eggs or gluten allergies, which as someone who in a past life was responsible for like mass flu vaccine campaigns and spent half my time discerning like, well, this person's allergic to eggs, so they can't have this one, but whatever, is really nice. It makes it a much more broadly available vaccine for folks. The DNA vaccines, right, the Johnson & Johnson that we're about to have in the US and the Oxford AstraZeneca, operate off a very similar model, right? So it's the same idea that you're giving your cell a blueprint to make the spike protein. It's just that blueprint is DNA instead of RNA. And it's DNA that's covered in, its envelope is made of this adenovirus. So adenovirus is a very common type of virus. Adenoviruses can cause like a cold. But they're very good at delivering themselves to your cells. And so that's why people, it's very common in science to use adenovirus as sort of a carrier. This adenovirus has been changed so that it can't make you sick. It can't make you have adenovirus symptoms. All it is a delivery system, an envelope for the DNA that tells your body to make the spike protein. So again, it looks very similar, right, to what happens with the mRNA vaccines, where it gets into your body, it delivers that instruction to make the spike protein, and then the spike protein goes out and it triggers your immune system to have a response against it. Just because it's sort of hot off the presses yesterday. I was finalizing my slides on this while listening to NPR and hearing all this about the Johnson & Johnson vaccine, because the FDA released some of the results of their sort of preliminary review of the vaccine. And it looks pretty good. So it's got 72% overall efficacy in testing within the US, which is up from sort of the preliminary studies that we'd seen. 64% efficacious in South Africa, where they're dealing with one of the new variants that we're concerned about. And 86% efficacious against severe forms of COVID, right? So even if you got it, you are much, much less likely to get really sick. It possibly has milder side effects than Moderna and Pfizer vaccines, which would be nice. And it's also suggestive of about 74% efficacy against asymptomatic infection. And I'm going to talk more about that in a minute, but basically what that means is the idea that it's not only preventing illness or severe illness, but probably preventing transmission as well. So we'll talk about that more in a few minutes. And just a little bit about the terminology, because you just heard me use efficacious very specifically, not effective. So you might be hearing this a lot, as you're listening to the news about the vaccines. And the difference is vaccine efficacy is talking about the percent reduction in disease occurrence in the vaccinated group compared to the unvaccinated group under these sort of very controlled conditions of like a study or very, very optimal conditions. Whereas vaccine effectiveness is really talking about the ability of the vaccine to work in real world conditions, right? So once we start kind of getting out there, with all the real world conditions and fewer controls. Almost all the data we have about the COVID vaccines currently is efficacy, because again, we just, until recently, we didn't have that much real world experience with them. We're starting to get some effectiveness data, and I'm going to present that towards the end. And I think that's actually some really exciting data that gives us some hope about the future of these vaccines. One thing people kind of want to know, and I think people had a lot of skepticism and concern about, was like, how was this developed so quickly, right? We went less than a year from when we were sort of like, okay, there's this virus, circulating to like, we have a vaccine, and that's unheard of and amazing and really an achievement of, science. But people were kind of like, okay, well, what was skimped on? What was skipped? Like, do we know it's safe? So I wanted to address that for a minute. So any vaccine, or any medication, any drug in the US that's going to be authorized to be given has to go through the Food and Drug Administration, the FDA. And it has to go through 3 levels of trials in people, where they're giving it to people and they're monitoring them for safety and for efficacy, right? Effectiveness under those controlled conditions. So the first level, the phase 1 trial, is very small, and it's really just looking at safety, because if it's not safe, we don't want to give it to a bunch of people, and we don't really care if it works if it's not safe. Then you give it, sort of a slightly bigger group of people, and you look at safety and efficacy. And then you do a phase 3 trial, where again, you give it to a slightly larger population. And part of the reason for this sort of graduated bigger and bigger populations is because you have more of a chance to see, those rare 1 in a million kind of side effects or adverse effects that might happen. You're not going to probably see that in 20 participants, but you might see it by the time you get up to thousands of participants. So once it goes through those 3 phases of trial, then it can go under FDA review. They can, approve it for use. And even then, they still continue to gather data on it as you go out to thousands and thousands and millions of people getting a drug or a vaccine. They do the phase 4 trial, which is again just sort of continuing to monitor the the drug or the vaccine. As you get into even bigger populations where you really might see some very rare, side effect, but something you might want to know about. So none of this was skipped. This was all done. We went through the phase 3 trials and we got to the FDA review, and none of that was skimped on. This is not as great. It's a little bit harder to read. It's just showing those same 3 phases of trials. I just want to show it because you can see here, right? They show years, right? Usually this process takes much longer. So how did we do it so fast? And it was really kind of just a nice coming together of things. So, sort of luck favors the prepared in some ways. Part of it is the nature of the vaccine. This is the first really widespread use of mRNA vaccines. There's an Ebola vaccine that uses this technology as well, but this is the first really mass deployed mRNA vaccine. But scientists have been working on this technology for 20, 30 years. So that, we were really fortunate that it was ready for prime time now. And we really, all of that sort of groundwork was laid. But the nature of the mRNA vaccine, as I mentioned, right, is that you don't have to wait to grow whole, viruses inside cells or whole bacterial cells in culture the way you do most vaccines, right? And cells are living things. They grow as fast as they grow. So that can limit, how fast you can produce a lot of vaccine. The mRNA vaccines and DNA vaccines, you can basically assemble. You can manufacture, from things in the lab. So you really just put it together. You don't have to wait for a living thing to grow, which can make the manufacturing much quicker and all the phases of the trial much quicker. Looking at also just the sort of the high profile, right, and the prioritization. It really shows what can happen when you really prioritize something happening. So, things that usually take a long time and going through those 3 phases of trial are things like getting the funding. Well, we threw a lot of funding, right? It was a global effort to throw a lot of funding at this happening. And so, the researchers weren't, spending a lot of time writing laborious grants and revising them and, trying to get the funding. It was there. It can take a long time to enroll clinical trial volunteers. Again, because of the high profile of this and people wanting to make it happen, they didn't have a lot of problem getting volunteers. And again, it's just, all the studies, all the levels of study basically got sent to the, TSA priority lane, right? So, nothing went and sat on a bureaucrat's desk for, months before it got reviewed, right? Phase 1 trial information came in, it got reviewed, moved on to phase 2. And they really eliminated sort of a lot of the waiting and red tape. Finally, there's the emergency use authorization. So what that means is that technically, this is not FDA approved. This is granted an emergency use authorization. And this is just a mechanism that the FDA has, and it's used under other circumstances as well. That just basically says, sort of under this urgent condition of a global pandemic, that, they will move back basically one step of it a little bit early. So what they do is they just shorten the follow-up of the phase 3 study so that, most of the data basically has 2 months of follow-up instead of longer, because the sort of cost benefit is in getting it out there to people who need it rather than, continuing to follow up and follow up and follow up. That follow-up is still happening. It's just that they're letting it be used while that follow-up happens. And particularly for a vaccine, where it's not something that, like a drug where you're taking it, over and over and over, and you might see more effects. For a vaccine, it's really, most of this effects, if you're going to see them, have happened in the first 2 months anyway. So it's really, a good use of that authorization. And then the manufacturer was able to sort of ramp up while the EUA was pending, which helped, again, just, be ready to hit the ground running with the vaccines. So I was going to talk a little bit about how we have done the vaccination strategy in the US, and then a couple of different international cases that tell us some interesting things. So of course, in the US, This will be out of date next week, happily. But in the US right now, we have the Pfizer and the Moderna vaccines, and those are given either 21 or 28 days apart. And the second dose is just a booster. It's not something different. It's just a second dose of the same thing. And really what that is just to give you a full immune response. So you get the first dose, you make an immune response. But then, it can kind of wane a little bit. And the second dose is really just to kind of really boost that up and strengthen and refine the response. And if you think about most vaccines that you ever get, you get a booster at some point. It's just that a lot of times you were a baby when you got the first one, so maybe you don't remember. And we're seeing a good immunity. So we're seeing the initial spike in immunity is happening about 12 days after the first vaccine, that already you're getting some protection in there. And then you get into the full protection. So this is 95% efficacious in Pfizer, 94.1% in Moderna. It's an A+ either, or A, I guess, A either way, very good, at about 5 to 6 weeks. And that's about 2 weeks post, your second dose, a week or two past your second dose. People I think have a concern about with supply chain issues, what happens if you don't get your second dose exactly on time? So for Pfizer, that's 21 days after your first dose. For Moderna, it's 28 days after. And per the CDC, basically, they don't want you to get the second dose ideally earlier than recommended. They'd rather you get it later. But there is a grace period of about 4 days beforehand that would not even be considered to be early, right? So 17 days for Pfizer, 24 for Moderna. Even then, they say if it's inadvertently administered earlier than the grace period, you don't have to repeat it, just continue on your way. And there's no maximum interval between the first and second doses for either vaccine. So, if for some reason you missed your second vaccine, you don't have to start the series over. You can just go get it and you're still considered valid. So the UK is actually kind of taking advantage of this strategy. So they've had the Oxford, AstraZeneca, and the Pfizer vaccines. And their strategy has been to delay the second dose to 12 weeks. So instead of giving it, at 3 weeks, give as many people as they can the first dose, and then, sort of wait 12 weeks to sort of spread the supply out among the population. The idea being, right, that we're seeing some spike in immunity after the first dose. So let's get everybody somewhat covered, rather than getting some people perfectly covered and some people, leaving them vulnerable to it. It's a strategy. It's a gamble, and they're doing studies and they're following up and seeing if this works. There's been some debate. So, that's the idea behind it. That's the potential benefit. The potential risk is, you're not fully protected until you have that second dose. So are you leaving people with some sort of waning immunity and with some vulnerability till they get to that 12-week mark and get the second dose? And from a population perspective, are you maybe selecting for variants then by leaving people sort of partially vaccinated? So there are arguments on both sides, and the sort of study is ongoing about whether that's going to work or not. Another interesting example is Israel. So you can see here, per capita or per 100 citizens, Israel is way ahead of the rest of us. So how are they doing it? Since December 20th, when they started their vaccination campaign, they've vaccinated about 40% of their population. Almost a third have gotten their second dose already. Among those over 60, more than 80% have already been vaccinated. And they have basically more supply than demand at this point. So anybody over the age of 16 can get vaccinated immediately. And that's really because of sort of the lower age cutoff of, who it's been approved for. So, I want some of that, right? How'd they do it? And of course, the answer is, money makes the world go round, right? So they entered into a contract with Pfizer. They've been very transparent about it, where basically they're paying a lot more. So they are paying about $28 per dose compared to about $14.50 per dose that the EU is paying, or $19.50 per dose that we're paying. In addition, another big deal is that they are saying we'll take on the liability. So in the US and the UK, or in the US and the EU, we're saying, product liability stays with Pfizer. Israel's saying we'll take it on, just give us vaccine. Of course, what's as valuable or more valuable than money these days? Data. So the other thing that they're doing is they're providing lots and lots of data about infections, about vaccination numbers, about patient demographics, Israel's electronic medical record system, which is very comprehensive, is able to send that pretty much immediately to Pfizer, which is like gold to them, to be able to continue to monitor the vaccine and get more data about how it's working and more granular detail on that. So in return for all that, Pfizer is giving them plenty of vaccine and basically is committed to give them vaccine until they've immunized 95% of their population. So that's how they're doing it. And it works. So in people over the age of 60, they're already seeing 56% fewer infections, 42% fewer hospitalizations, and 35% fewer deaths after the second dose than they were seeing. They're really, bending the curve very dramatically in the right direction. Now, another thing we probably want to, be sure about, right, is can the vaccine prevent transmission? Because, I think one thing that we're saying a lot in the US in our messaging, which I think is a mistake and going to come back to bite us, but the messaging has been very much, if you get your vaccine, don't change anything, right? Don't change anything about your behavior. Keep acting as if you could transmit COVID because we don't know for sure that you can't transmit it. Because initially, the trials that were provided to the FDA were looking at simply getting COVID disease, right? So they weren't looking at can you be harboring, SARS-CoV-2 virus and be asymptomatic and be transmitting it around still. They were only looking at does it prevent you from getting sick. However, even in the initial trials, Moderna was, when people came in for their second shot, they were just kind of giving them the nasal swab for COVID to see if they had it. And they've now submitted, sort of a supplement to their FDA submission that says, even at that point, right, which was when they were coming in for their second shot, so they weren't fully vaccinated yet, they were already seeing a decrease in people who had asymptomatic COVID, who were harboring COVID and could potentially spread it. So 14 of the 14,000 vaccinated people had it, compared to 38 of the 14,000 unvaccinated people that were their control group. So that's, encouraging data. And now we're seeing even more encouraging data that, really it's preventing transmission and not just preventing illness. So Israel providing their data, right? So this also came out very recently that looking at that data, the vaccine is preventing symptomatic and asymptomatic infections by 89.4%. Then when you look at symptomatic cases only, it's even better, 93.7%, and deaths are almost completely eliminated. But that's really exciting, that 89.4%, that's suggesting that, again, you can't even transmit it. You're not having asymptomatic infection once you have the vaccine. UK, right, our old friend, did a study of their healthcare workers. And they did that because healthcare workers are being screened regularly. They're being tested regularly. So, this is actually our first effectiveness, right? So real world, how does the vaccine behave data? And so they were looking at healthcare workers who had had the Pfizer vaccine. And it was actually 72% effective in preventing infection 21 days after the first dose, again, only the first dose, and 86% effective in 7 days after the second dose. So, that's at the point when you're really starting to be considered fully vaccinated. And that's really good effectiveness numbers. You don't, this is not like grades. You don't have to get an A. So if you look at something like the measles, mumps, rubella vaccine, that 86% is pretty much similar to how well that vaccine prevents against getting mumps. So it's about 88% effective against mumps. So, that's not something that we're really out there worrying about, right? So that's a really good effectiveness number. Seasonal flu vaccine, year to year, the effectiveness, about 50%. And that's still a really, really, really good, valuable vaccine. So, those are really good, valuable, numbers. That should give us hope that we really will prevent transmission and potentially, get back to normal life. Now, when we get back to normal life, I can't tell you. Dr. Fauci can't tell us, and I am no Dr. Fauci. I'm getting towards the end. I see Tim's note. We're wrapping up. So, getting back towards normal, our goal, right, is herd immunity. And herd immunity is just when enough of, the community is immune to a virus that can't spread easily from person to person anymore. So it doesn't have to be everybody, right? It's just enough people to keep the unvaccinated people safe as well. And there was a recent study that did some modeling that showed that It kind of, there's a lot of variables that it depends on, but potentially, if there's an efficacy of at least 70%, then it'll prevent an epidemic. And if there's an efficacy of at least 80%, you can actually basically put out the epidemic without even all the other measures that we're doing, social distancing and all that. So that's encouraging news because we're seeing, it looks potentially like we're seeing that kind of effectiveness. Now it also depends on how many people get vaccinated. So if only 50% of people get vaccinated, even 100% vaccine efficacy is not going to get us to herd immunity. So just to give you a little bit of an idea, these are the sort of the different curves of how they model this. And there's just a lot of different things that go into it. So they modeled it based on like how much of the population had COVID, how much got vaccination, and then the time frame of it and everything. So that's why it's really hard to sort of give a very exact answer to when will we reach herd immunity, because there's so many variables that go into it, and that's not even counting the variable of like human behavior. Wrapping up. So will the vaccine be effective against the new variants? That's another big concern people have, right? We're seeing all of a sudden, yay, we have the vaccine, but now we have the new variants, and is that going to like mess up everything? And the answer is, so far, knock on wood, hopefully not. So far the variants are new, therefore our data is pretty new, but it looks like the Pfizer vaccine is slightly less efficacious against the variants, but it's probably still good enough. Oxford AstraZeneca, probably, protecting well against the UK variant, maybe not so good against the South African variant, although it should at least still prevent against severe illness. And Moderna is looking like it's actually effective against the South African variant as well, although, maybe won't be as long lasting protection against the South African variant. And really here, our biggest protection is time, is vaccinating everyone as quickly as possible. Because the whole deal with the variant is just as long as the virus is basically allowed to like go out and replicate in the population and, have new hosts, and there's always then, there's more virus around, there's more chance for just a little mutation to happen, and that's where you get the variants from. And if there's a little mutation that happens that helps the vaccine, or that helps the virus be, more effective, then that's going to become the predominant strain. So really the biggest thing is just time and getting people vaccinated as quickly as possible. All right, couple last quick questions to finish. Can you mix manufacturers for the first and second dose? Can you get Pfizer for one and Moderna for the other, or vice versa? The CDC says basically, they don't say no, they say we just don't have the data. That is something that is under study, but we just don't have data to say yes, it's fine, or no, it's not. They work by the same mechanism, so probably, but we just can't say for sure. The UK is saying a little bit, again, their strategy is a bit more just get people vaccinated. So they're saying, we prefer that you do the same, but if you have to mix manufacturers to get people their 2 doses, do it. Why do they have to be kept at sort of such varying conditions, right? Because there's, one that has to be kept at like -70. There's one that can last a little longer at freezer temps. Johnson & Johnson can actually, last much longer at sort of regular, more freezer and fridge temps. And that's really just because the nature of what's in them. So mRNA, remember, it's only meant to go from the nucleus to the cytoplasm, to the goo of the cell. It's not meant to be a long-lasting thing. So it's not very stable. It has to be kept very, very, very cold to help it be stable. The Moderna mRNA vaccine has a slightly something about the lipid package they're not telling, is slightly more stable. And so it can be, it can tolerate a little bit more temperature variants. And the DNA is a little bit more stable than that even. And the adenovirus, that cover, is also sort of more hardy. So that the Johnson & Johnson vaccine, which will be, a nice thing about it, can tolerate sort of a wider array of temperatures. All right, last slide. So once I get the vaccine, can I test positive for COVID? And the answer is no. If we're talking about viral testing. So if you're getting tested to see if you have COVID, it is viral testing. Since we're not putting virus in your body, there's no reason to think that the vaccine is going to cause you to test positive. If you test positive after you've had your first dose or something, it's probably COVID. You've probably been exposed. if you're still having antibody testing, which we're not really doing that much anymore, antibody testing we were using to see if people were exposed to COVID or not. The official CDC answer is we don't know. It stands to reason that it might affect it because it's seeing if you have an antibody response, and now you will have an antibody response. But the official CDC answer is we don't know. And finally, there's a jillion things out there that people are saying that that the vaccine does, other than cause you to have an immune response against COVID. And I try to be a evidence-based person here, and the evidence shows us that if we repeat those conspiracy theories, even in the process of debunking them, that it actually strengthens them. So I'm not going to repeat any of them. You can think about your conspiracy theory here, but the answer is no. Really, really no. And I sort of appreciate the faith in science, perhaps, that it shows that people think we can do all these other things, but all the vaccine is here to do is make you immune to COVID and stop this this pandemic. So with that, I'm going to hand it back over to Tim, and he'll tell us what's next.
Hi, so I'm Kim Davis. I'm the admission counselor for the Master Public Health Program at Elmhurst. Before we get to the Q&A portion, I'm just going to show you a brief video to give you the opportunity to learn a little more about our program. But first and more importantly, I wanted to share, due to the demand in the field and the need for public health professionals, we are offering a $5,000 scholarship to any student who starts in the program this year, which is really exciting. So let's go ahead and take a look at the video.
Public health is focused on prevention of health problems, and it's focused on treating populations and groups of people. So you can really, do things that prevent people from even developing disease and keep people healthy and protect whole communities. If you're really looking to make a big impact like that, public health is a great field to go into. The ideal student for this program really is just someone who's intellectually curious and who wants to learn and who wants to make a difference in their community. You can come from any sort of background, and we actually really welcome that, because again, we're really looking at how can we come from all different perspectives and really use a multidisciplinarity to affect better health in our communities. So if you come from a non-science background, we're really happy to help you kind of get caught up on that. In our program, they'll get all the normal things that you would. Public health is focused on prevention of health problems, and it's focused on treating populations and groups of people. So you can really, do things that prevent people from even developing disease and keep people healthy and protect whole communities. If you're really looking to make a big impact like that, public health is a great field to go into. The ideal student for this program really is just someone who's intellectually curious and who wants to learn and who wants to make a difference in their community. You can come from any sort of background, and we actually really welcome that, because again, we're really looking at how can we come from all different perspectives and really use a multidisciplinarity to affect better health in our communities. So if you come from a non-science background, we're really happy to help you kind of get caught up on that. In our program, they'll get all the normal things that you would expect in any MPH program. So biostatistics and epidemiology. They'll learn about community health. They'll learn about health policy. But we also have a few things that make us unique. One is a one-credit course that is about your professional development as a public health professional and helping you to find your niche within public health. And then the other is a course specifically around leadership and innovation, and we'll be taking techniques from other disciplines and having guest speakers from other disciplines like business and data science and even from our performing arts community here. And that will culminate in a practicum and a capstone where they actually can go to an organization in their community, wherever they are. There are a huge array of jobs that you can go into, a local or state or even federal health department, in an academic setting, doing research, in a community setting, working with people doing health education. The MPH is fully online. It's designed to be done in 2 years. You can do it in a way that fits into your life, in a way that you can still keep your job and still keep your family commitments. We also offer the MBA option, where with 1 year of additional study, students can graduate with an MBA in addition to their MPH. So the Master of Public Health program at Elmhurst is really focused on leadership and innovation and equipping our students to really go out and make a change.
All right. Thank you, everybody. Thank you, Molly. That was a lot of information in a very short period of time. We're going to move right into some of the questions that were chatted in here in the last 10 minutes or so. Okay, so I'm going to throw out the first question from Joanne. Are there any tools or websites out there that help you sign up at multiple places to get the vaccine?
That's a very good question. I'm probably not the best resource for that. Obviously, it depends on where you live. So, I'm in the city of Chicago. I can sign up on, one website and it directs me to a bunch of others. And there have been, a few, I saw on the news the other day, there was a young man who's created a website, but I don't know off the top of my head, that helps people kind of be more of a one-stop shop. But it really depends a lot on where you are. And I'm not aware of any really great, like, one-stop sites.
Kind of a related question. Are there any, obviously there's differences between the mRNA and the DNA vaccines. Is one better than the other? And I know they have, different efficacy rates.
Yeah, so no, like the best thing to do is just get vaccinated. The best thing for you personally, right, for your own risk of getting COVID, and for us as a population to knock out the pandemic, right, and to get everyone vaccinated as fast as possible so we don't get more of those variants. Get vaccinated with whatever you can get in your arm. There are those small sort of variations that I talked about, slight differences in efficacy or slight differences. It sounds like say Johnson & Johnson maybe has a lower side effect profile. At this point, based on what we know at this point, it's not enough to like really prefer one versus the other. Right now, you're not going to get to choose one versus the other, most likely. And like I said, it's even looking at those efficacy numbers between the Moderna and the Pfizer, right? 94 versus 95. This is not like you're getting a grade in your class and you really want that 95. Like it's an A either way. It's wonderful. It's not a significant difference. So just whichever vaccine you can get it.
And I think there's been some general confusion out there in the public that the vaccines are a cure for COVID-19. That is not the case. These are not cures, just like the flu vaccine doesn't cure the flu virus. Here's a question from Julia. I recently read an article that suggested if you've already had COVID, you only need to get one dose of the vaccine. What are your thoughts about this?
I have not seen that article, so I'm interested to go look at that up later. I'm sure the thought there is right that somehow you're already having had COVID, then you have some antibody response, and so like you sort of had like the first vaccine and getting the second one might be your booster. Again, I'm not aware of it. I'm guessing the CDC probably has not issued any formal ruling on this. And my thought would be right now, before we know more and before this has been like a well-studied thing, it's still better to get the second dose because we don't know how long your immunity lasts and how strong your immune response is from getting COVID naturally. And there is some thought that it depends on like how sick you were as to how strong a immune response your body created. So without knowing more, without that being a well-studied, phenomenon yet, I'd say you still need to get both. But new data may come in and that may change.
I mean, there's no harm in getting that second dose. I mean, that's the protocol. So we're going to stick with that. Get vaccinated and get both doses. Okay, Molly, next question. Dominic asks, will people who are taking medicine to make them or are immunocompromised still be able to receive these types of vaccines?
Yeah, so everything I've read so far is still suggesting that people who, okay, so obviously like with the preface of discuss this with your doctor because there are, I'm sure, subtleties of different conditions and different medications any individual may be on, right? This is not medical information. But from what I've seen so far, just from, FDA, CDC, they're still suggesting that people who are, immune compromised take these vaccines, with the idea that you should still produce some immune response. And, and it's even more important for you to be protected, right, against COVID than folks who have normally functioning immune systems.
Next question. Frida heard on NPR this morning that a third dose is being recommended to help against the new variants. Thoughts on that? I mean, there's probably no data out there yet.
There's definitely no data. And I did not, I listened to NPR this morning too. I did not hear that. But I did hear yesterday on NPR, they were talking about, and I wonder maybe if this is what you're talking about, Frida, that they were saying maybe depending on what happens with the variants, what may happen is that the existing vaccine manufacturers may create, they may start creating new variants of the vaccine that address, right, they're specific for the variants that are out there. And if we find that people are needing, specific vaccination against those new variants, there may be, like getting another booster down the line of those specific sort of those variant shots. There's not data out there yet. I have not heard from any official sources out there yet that that's something that people are saying needs to happen or is going to happen. And it looks pretty good that, the existing vaccines are efficacious enough against the variants that we have right now. Again, it's an evolving situation, so that could change.
Molly, we've got a couple questions regarding any information about deaths or reactions related to the vaccine. And then kind of related, are there any expected long-term effects of bypassing DNA to get to the mRNA? I don't know if anything exists out there yet in terms of, this is still pretty new.
Yeah, so the safety data has been excellent, on the vaccine, hence it being approved. And obviously, right, it's the risk of people, getting sick and dying from COVID, which is huge, versus any side effects of the vaccine itself. So it's been very, very favorable. That's why they get the emergency use authorization, because they say, the risk benefit is definitely there of getting the vaccine. And again, it's got a very low, the nice thing is it's got a very low, even like allergen profile because of the way it's manufactured compared to other vaccines. So we don't have firm data out there on long-term effects of the vaccine because we don't have long-term yet. We've just started giving it to people, widely in a few months. So there's just not possible to have long-term data. There's no big reason to think that there is a special risk from an mRNA vaccine. For one thing, the mRNA, right, it's very fragile, it's very short-lived. So it doesn't stick around in your body. Once it's done its job, it pretty much, it gets sort of metabolized, destroyed very quickly. Again, it never goes into the nucleus of your cell where the DNA is. It's not messing with your DNA at all. It just stays out in the cytoplasm and makes the copy of itself and then basically gets destroyed. Again, we don't have long-term data on the safety of the COVID mRNA vaccine because we've been working on the development of the whole mRNA vaccine idea for 20, 30 years. We do have long-term data on the safety of that, and it looks very safe. But so far it looks good.
I'm just trying to summarize. We're running out of time here. I do want to be respectful to everyone. Let me just see if there's a couple of other, thoughts on the variants and the effectiveness of the current vaccines. We've been hearing more and more that yes, they are effective versus the South African, but not the European. So any more up-to-date information that you can share on the effectiveness of the vaccines on the variants?
Well, so that was the last couple of slides, right, that I talked about, that it looks like each of the vaccines is decently good against the variants. It may, again, we don't have like the widespread data to say for sure that like we won't need, that sort of booster eventually. But, if you refer to that last slide, right, the numbers are pretty decent on the efficacy for each of them. It looks like the South African variant is a little bit more of a trouble as that goes than the UK variant. but it does look like the vaccines are pretty efficacious against each. It certainly in preventing severe illness, which, you know, at least takes the burden off hospitals and makes people safer, and probably against transmission, but we don't have as much data on that yet. And again, the real thing here is just getting people vaccinated as quickly as possible, so there's less vaccine out there mutating and creating new variants all the time, and we're not having to chase them, right? We're not getting behind. We're proactively just stopping the transmission so that it stops, you know, the possibility of new variants.
Possibly a final question, and I'm going to go to Laura's because it's a question that I personally have as well. Do you think we're going to need to be vaccinated on an annual basis, kind of like the flu vaccine?
Yeah, I mean, you know, far be it from me to say anything that Dr. Fauci isn't saying. You know, and last I saw that question answered by him, he was not committing one way or the other. So, you know, we just don't know yet. Yeah, we don't know. It may be, you know, if we get far behind enough on these variants, that it will become a thing that's circulating, and that, you know, we have, right, like with the flu vaccine, right, we each year is sort of a different formulation against different variants of the flu. It may be like that. It may just be, you know, we're able to bring it down fast enough, it really stops the transmission, and we're done. We just don't know yet.
It sounds like for now, we just need to be focused on getting as many people vaccinated as possible, get towards that herd immunity rate of 70% or above, so that we can move into phase 5 and, you know, get back to life as we, you know, knew before the pandemic hit, you know, over a year ago now. All right, we're going to wrap things up, and I apologize, we did not get to all the questions. As I mentioned earlier, we are recording, and we'll send you all a link to this. I'd like to definitely thank, you know, Dr. Tran. The information presented was fantastic. Kim Davis, thank you. Sherry Baccaro in the Office of Admissions, she's been working tirelessly behind the scenes to get the event up and running, so thank you, Sherry. If you are interested in learning more about our Master of Public Health program or any other of our 20+ master's degrees or graduate certificate programs, please mark your calendars and join us on Saturday, April 17th. That's the date for our spring graduate programs virtual information session. So you can go ahead and register at elmhurst.edu/choose Elmhurst, and we'll go ahead and send you the Zoom link, and you can join us from the comfort of your homes. In the meantime, if you have questions regarding graduate studies at Elmhurst College, please feel free to reach out to the Office of Admission. The phone number there, the website, which is a link to all of our graduate programs, as well as our email address is there for your convenience. Once again, thank you all for joining in the conversation today. Stay safe, wear a mask, continue to social distance, and please get vaccinated as soon as you can. Have a great day, everybody.